Bismillahirrahmanirrahim. In today's lecture, we're going to look at keywords, internal storage, and the operators. The source of the material used on this slide is shown here. Every language has got a set of keywords. Every programming language has got a set of keywords. The Java's set of keywords is shown here. The source for these keywords is shown as well. These keywords have a special meaning in Java language. They cannot be used for any other purpose. They cannot be used as a identifier or as a class name, as a method name, as a variable name, because they have special meaning in the language. Two keywords, goto and const, they are in this set, but they have no significance, no importance, no meaning in the language. If this is so, why are they here? Goto was an old way of making a jump from one point in the program to another point in the program. Maybe you are executing line number 5 and you want to make a jump to line number 50. So goto can help you go to that location, but this way of jumping within the program creates a problem. So this way of shifting the control from one point in the program to another point in the program is discouraged. Instead of this, we have other ways of doing it. So that's why this goto is here, because many of the programming languages support this. The word goto is keyword, but it has no meaning because the community has discouraged the use of this way of shifting the control. The const keyword is actually the reason behind the const is used as a special keyword to define constant variable in C, C++, and many other languages. The developers of the language, Java language, they were actually C++ programmers, C programmers. So they actually did not want to create a confusion by using the const as a special purpose word here. So this is the reason for these two. Few keywords were added in the later version and mentioned here. Null, false, and true cannot be used as, are not keywords, but they cannot be used as identifiers. They are literal values. They are actually values for the variables. Moving on to the next slide, we have talked about data type previously. Data types has got, every programming language provides two kinds of data types. Why data types are important? Every program allows you to manipulate data. Manipulating the data is the core, is the main thing a program does. All the things we do in the software in a program is actually manipulating the data. Data comes from user or come from somewhere else, gets manipulated, transformed, and outputs are created from the data. So doing the processing on the data is easier if we know the type of the data. If we know the type of the data, we can apply the appropriate operation on the data. As we have seen in our previous example, the plus operator was used to add two numbers, and the plus operator was used to concatenate two strings. So knowing the type of the data helps the operator to behave in a certain way. So knowing the type of the data makes us do specific targeted behavior operation in our language. Java supports 8 primitive types as shown here. Out of these primitive types, int, long, short are for whole numbers, integer types. Float, double are for real numbers, numbers with fractions. Char is for character, boolean is for true, false, and byte is for 8-bit value. User-defined data types. User-defined data types are used if the programmer needs a bigger kind of these types, needs to create a structure for bigger data. For example, student as a data type, we need to hold different information of the student, the name, the address, the age, the date of birth. So we can create a student data type. This is also referred to as data structure. So every language provides a mechanism, a way to create user-defined data types. In Java, we create user-defined data types by creating classes. We have used string previously, we have used scanner previously, and we have created IO program class in the previous program. So these are three examples of user-defined data types. When we say a variable has a name, memory size, the value, and the identifier. So the memory size is actually the tells us that how big value can fit into that variable. For example, int has got memory size 4 byte, long has got memory size 8 byte, short has got memory size 2 byte. They all three are representing the numeric whole number data without the fraction part. So the value stored in int is smaller than the value stored in the value stored in short is smaller than the value stored in int, and the value stored in int is smaller than the value stored in long. Okay, implicit conversion and explicit conversion. Many times in our processing, we need to convert the data type. For example, we have two variables. One variable is of type long, let's say x, and another variable of type one variable of type int, let's say x, and another variable of type y of long, let's say y, x and y. If we assign the x variable to y, there's no chance of losing data because the size of the data fit in int can also fit in long because long is bigger type, bigger size. So there's no problem, but the conversion will happen and that conversion is implicit, automatic. Whereas explicit conversion is in the contrary. If we try to assign a bigger type variable to a smaller type variable, then there is a tendency of losing data. So we make it convert explicitly because the responsibility of this conversion falls onto the programmer, whereas responsibility of this conversion falls onto the language provider. That's why it is implicit. There's no chance of losing data. There may be a chance of losing data. Then the programmer should know what he's doing. In our previous lecture, we talked about different packages and the classes and the methods we used, how one knows these methods, how to find out. So for this, let's go out of these slides and go to the link here. This is the link for the documentation for the API. Going to this link will bring us to this documentation. This documentation has got the details of everything, the packages. The package we have used so far is java.lang. Go to lang package, and then within the lang we use system. Let's go to system. Within the system we use out. Out is one of the variable, one of the member. So go to out. Out goes, it's got many methods. We use the sprint ln method with a string value. So this going to this will tell us how to use this method. This will tell us everything that what this method will do. Similarly, we can go to the other packages. The other packages we have used was one was java x.swing. So let's go to java x.swing package. In that we use JOptionPane. Here is the swing package. We go to JOptionPane. Here's the JOptionPane, and in this we go to show message dialog. So let's search for the show message dialog and search for this method. There is a method with 4 arguments, 4 parameters. Let's look for the one we use. We use this one. We pass the null value here and we pass the message to display here. This null was to tell that there's no parent. So this is the way many of the programmers, actually no programmer remembers all these packages or the members of these packages or the methods and how to use those members, classes of those packages. So remembering the documentation, the link, and knowing how to use it is the key to use these methods. Okay, moving on. As we said, the core objective of a program is to be able to manipulate data. Talking about typed data types, type data. Now coming to operations. There are many operations in Java. Some are unary operators, some are binary operators, some are ternary operators, conditional, logical operators, bitwise and bit shift operators. These bitwise and bit shift operators are rarely used and used by the special programs or few developers who are actually working at low level or at the networking level or working at the hardware level. So let's take an example of few of these operators. We'll take example of these 2 unary operators and this ternary operators. The use of the mathematical operator we have seen previously, add, and we have seen the equal sign, the use of equal sign. So let's take an example of few of these in a program. Here is a program. In this program, we have got this simple program. I have declared a variable x of type int having got value 5. So a variable has got 4 things associated to it: the type, the name, identifier, the value, and the size. Okay, so here we have got 4 things: the value, the size, the name, which is the identifier, and the type. Okay, so there are 4 things associated to every variable. Now in this line, what we did, we say x is equal to 5, then we print out the x plus plus. Plus plus is the unary operator. Unary operator has got one operand x. If we previously we used plus between 2 numbers, x plus y. So plus is a binary operator because it's got 2 operands x and y. Similarly, when we concatenated 2 string 1 plus string 2, again 2 operands, 1 operator, binary operator. Here 1 operator with 1 operand. So this is unary operator. What we have done here, this is called post increment. This is called the pre-increment. If we use the 2 plus symbols after the x, we write x first, then the 2 plus symbol, then it is called post increment. If we write the 2 plus symbols before x, it means pre-increment. Post increment means wherever we are doing this, we use the current value of x at that point, and then after using it, we increment the x. As you can see here, the first line, when we execute the program, the first line, it prints the current value of x. After printing the current value of x, the value of x has been incremented by these 2 plus symbols. How do we know that? Because we immediately after we print the value of x again, then it prints 6. First it prints 5, the current value of x, then it increments the value plus plus, and then when we display again, it prints the value 7. Looking at the third line and this line, we do the pre-increment. The meaning of this, before we actually use the value of x at this certain point, we increment it first, then use it. So here the value was 6. Now when we come here, before we use, we increment. From 6, we make it 7. When we make it 7, then we print. So it becomes 7. Similarly, post decrement and pre-decrement. The job is the same. Here, the number is being incremented. Here, the number is being decremented. Okay, if we say that what is the alternate, if I don't want to use this, but I want to make the same effects in my program, what I can do here, instead of using the post increment, I say x, and then right after I say x is equal to x plus 1. So I can say x is equal to x plus 1 and remove this post increment. It has the same effect. It has the same effect as it was previously. Now I have to write extra code, extra line of statement. So instead of extra line of statement, I put that post increment here and save some time for me. And similarly, if I don't want to use the pre-increment, then I have to write x is equal to x plus 1 before this line, then print x to have the same effects. The one ternary operator we are using is this one, question mark and semicolon, which we looked at here. Here, ternary operator is a shorthand for if then else statement. This program is saying if x is equal to y, this double equal is actually a comparison. Are the two sides equivalent? If they're equal, if x is equal to 7, the value of x is 7, which is actually 7 here, then we print yes. If x is not 7, we print no. So as you can see here, if I execute the program, 5, 6, now I cancel the plus here and I put it here, same effects. X is 7. So after, because x was 7, it print yes. What if I say x is equal to 8? The answer is no. Now the no will print here. So this is a simple example. Similarly, you can make many simple examples just to see the use of this operator. Okay, we come back here and move on. One more thing important is the precedence and associativity of the operators. In an expression, there may be many operators written from left to right. Which one to perform first? As we know from the general normal mathematics, if in an expression, if we try to write multiplication, division, addition, subtraction, all at the same time, then which operation to perform first? Obviously, wherever in mathematical expression, wherever we see the brackets, if we see the brackets, that part will be calculated first. After that, we'll see the precedence that which one comes first. If we got an expression with many plus, minus, division, subtraction, then we do the multiplication, division, remainder. This has got the higher precedence. So the precedence is from top to bottom. This has got the highest precedence, then these operators, and then this is the type conversion. This one is the type conversion. We have looked at the explicit type conversion in the previous slides here. This one here, this is the type conversion. And then the multiplication, division, remainder, addition, comparison, ternary operator. What if they have got more than one operator at the same level of precedence? What if in an expression we've got plus and minus both? Then we move from left to right. Whatever comes first from left to right, we perform that. So left to right, left to right, right to left, right to left. This tells us the associativity and this tells us the precedence. With simple examples, the one we saw on in the NetBeans, You can all check the effectivity and the functionality of these operators. Okay, if we stop it here, until next time, take care.